My name is Zamzam. I'm going to talk to you about multi-peer connectivity. So a little bit more about me is that I'm working currently as an engineering manager at a company called VO Technologies. We work with a sport camera based in Copenhagen. And let's get to the topic. So what is multi-peer connectivity? So it supports the peer-to-peer connection between devices, and it's used for discovering devices nearby. In iOS, it is used. The framework uses the infrastructure Wi-Fi. It uses the peer-to-peer Wi-Fi and also the Bluetooth. And in macOS, it uses the first two, but then it also uses Ethernet. So it like kind of wraps around the whole thing and then makes use of these frameworks to be able to connect to nearby devices. And it is also like from here, that is only for iOS. So that's one of the things with the multi-peer connectivity. So again, you might ask why you would want to use multi-peer connectivity. The reason could be that it is decentralized network, meaning that you don't have to transfer data to internet or like a server. So you can just use a multi-peer connection and transfer data between devices locally. Again, you don't need to have internet, so this could work without any internet or any Wi-Fi available. It is ease of use. We'll see about that, but it is necessary, like relatively easy. It has adaptive connectivity, so the framework will take care of a lot of connection. So if it breaks, it will help you. It will take care of some of the things for you by default, which helps. And the versatility, which means that again, it will have the option of taking care of some of the things for you, and you don't have to worry about that. Then you might ask, why not? The reason for that is that it has limited range. So if you are, for instance, within, I don't know, like 100 meters or within the Wi-Fi network that they are connected to, it will work. But if you walk further than that, then the connection will be lost. The performance variability, which means that it could work differently depending on the situation. Sometimes it works really good, but like depending on situations, then it could actually have different kind of performance. Complex network management. So even though it takes care of a lot of things for you, but then sometimes you have to do things yourself. So then it could become a little bit more complex. Compatibility. So it only works within the iOS, macOS, tvOS framework. So if you are planning to use it with Android devices, it wouldn't work. So it is only within the framework of iOS and Apple ecosystem. Then you might question what it can be used for. Collaborative tools. So if you are working on a collaborative tool that is like people around something and you want them to collaborate on the same app or like same project, then you can use this. Of course, it can be used for messaging. So if you are having if you want to just have a messaging app for close people who are in the same room, you can use this one. Education. So like for a classroom, it can easily be an app that's used for education. Location-based services and social networking. And of course, my favorite is gaming. So you can definitely use it for gaming. Now we're going to get to the key concept of the framework. So we have a session object, which is, it's called MC session. It supports communication between connected peer devices. Then we have the advertiser object, which is, it's on the name, so it uses you use it for advertising. And then we have a browser object, again on the name, so you use this for browsing for the peers. Then we have the peer IDs, and the peer IDs are the uniquely identifier for the app. So when you're using the multi-peer connection, each of your devices will need to have a peer ID, so that then you can use that to be able to connect to multiple devices. How it works. So you have an advertiser and you have a browser. The nice thing about the peer-to-peer connectivity is that you don't need to have one device as the advertiser and the other one as the browser. So each device can be both advertising and browsing at the same time. Then what happens is that advertiser makes the device findable, and the browser is used to search for the devices. When the browser finds an advertiser, then it can send an invite to the advertiser. The advertiser receives an invite. It could choose to accept or reject the invite. If they accept the invite, then they have a connected session. So now that they have a connected session, they can start sending and receiving messages between the two of them or more of them. So what I'm going to walk you through today is a basic tic-tac-toe game. So we're gonna have two apps that are connecting through tic-tac-toe, and they'll be playing XO together. So we're gonna find nearby players, and then we're gonna connect to one opponent, and after that, we're going to play. So one of the very basic things that you have to do when working with multi-peer connectivity is that you need to set up the info peer list. So you need to, of course, get permission from the user to get access to their Wi-Fi and network. And then you need to add these things to your info peer list. So it's the name that you use over there. So here I use SwiftCraft Play. That's important because that's the same thing you're gonna use later on. So we have an MC manager. This is the class I have that takes care of all the things for our game. And the thing about it is that you can have, so you need to have a service type. And this service type, the name is the same, it has to be the same as the one that you had in your info P list. Then you have the advertiser. So it's an object of MC nearby service advertiser. And you have the browser. You have a session. And you have like player. So here I have the current player, I have the opponent, I have the available players, which is the list of all the available devices next to it. Then the player. So in my case, I have a player model that has MC peer ID, which is the unique identifier of that device. We'll get to that later. It has a name and it has a session. And this session, state session, it kind of shows the state that the device is in. It could be connected, disconnected, or connecting. And then we have the player type. And in my case, the player could be X and O. You could have multiple player types. Now we're gonna set the environment. So we're gonna initiate the MC peer ID. So the MC peer ID is initiated with a display name, with a string. A common problem is that the MC peer ID, you can initiate it with a display name, but it wouldn't, so if you later on you want to create or use the same peer ID, you cannot just create another MC peer ID and give it the name. It wouldn't be the same. So you have to store that. And the way to store that is with NS archiver. So you cannot just save the name and then create it again. So you have to, because it conforms to secure protocol, so you have to store it in a different way. Then you have the current player. So that's my player, which is initiated with the player ID, with the peer ID and the display name. We have the session. So from session, advertiser, and browser, all of them use peer ID to be created. In this case, we are creating each session per player, but you can have one session and then other players would connect to that. But this was the simplest way. So each player would have their own session. And you asked me a question before the talk of like, so the session itself has a limited of 8 devices, but then you can actually use, so it could be that like one device have 8 devices and then the other device will have 8 other devices. So there are workarounds how to connect more devices together, but the session itself can have a limit of 8 devices. Then we have the advertiser and we have the browser. And all of them are connected, are initiated using the peer ID. And we have the delegates. And these delegates are basically everything you have to get info from the multi-peer connectivity. There is a way that you could use or build your own, don't use these things and use your own, but then it will become much more complicated because you don't have the delegates and access to all of that. So in our app, now we created our manager, so we want to start the session. So at some point in your app, you have to start the session. And this is start the session, as I said here, all the devices are working as an advertiser and a browser. So each of them can become, can advertise and browse at the same time. And then I have, so in my game, I have different states of view that app changes between them depending on the state of the game. So the view states that I have in my app are these. So I have the ad player. So in this case, the app is open. I haven't put much time into design, as you can see. It's just like an ad player. And then when you press add player, then it goes to the state of finding player. So it will start looking for nearby devices to see which one they can connect to. And then at the end, we get to the play option when everything is connected. So in the add player, when the user taps the button, we change the state to the finding players, and I added the logic that the first player will be player X, so they would start the game first. And now we need to have a list of players. So how do we get the list of players and show to the user? There is a browser view by default that Apple provides, but it's in UIKit, so I didn't use that. I'm using SwiftUI, so I created a new one. So how do we collect all the available players? So you remember the nearby service browser delegate? When you implement that, it gives you these two functions, and these must be there. So one of them is for finding a peer, and the other one is when it is called when they lost the peer. So when the peer is around, this delegate is called, and when the peer is not around anymore, the other one is called. So yes. So now that we have our available players, so in that delegate, we keep track of how many players are around and how many players are not around. Then we can show them in the list here. So in my case, I just had one other device next to me, so I could find it over here. Now I want to connect to that device. So I press invite, and then this is the code that you need to use when you want to invite a peer to join to your session. So when you use this code, then the advertiser delegate comes to play. So the advertiser delegate is called, it has this function that says received invite from the peer. In this case, what you can do is that you can show an alert or show like something to the user that another device wants to connect to you, or you can just connect. So the strange thing here is that Apple doesn't require you to show an alert, because I assume it's because at the very beginning you've already accepted for other peers next to you to connect to you. But in this case, you can just connect to the other device when an invite comes through. Yes. So the session delegate. So now we've gone through how do you browse for peers, how do you connect to peers, and now the peers are connected, so the session is now connected. Now we want to see how do you transfer data between the peers, and that's usually the point. So like you want to do all of that to get to this point to be able to transfer data between the devices. So when we are using this, it's called MC session delegate. So it has multiple functions. One of them is when it is called when the session, when the state of the device is changed. So that, you remember we had it as part of the things we had in our player. So this is where you can actually know when a session is, so when a peer is connected or disconnected or connecting. I wish they had one more, which would be trying to connect, but not connecting. So the connecting is still, it happens at the point when the user accepts the invitation. So that's the point when it goes to connecting. But between that point, I think that will kind of fall into default that they don't have the state for that. So what I want to do in my app is that when the phones are connected, I want to take them to the player state. So one of the phone has the add player goes into this one. The other phone could still be on this page. And when I press invite, then I want to take everything to that to the player state. So then we get to the data handling part. So we have these functions for sending data between connected peers. One of them is the message. So it's just like a normal data that you can transfer. The other one is send resource. So for instance, if you want to transfer images, you can use send resources. And the other one is for start stream. Opens a byte stream to a nearby peer. And this is based on documentation, is used for when you want to transfer something live. I wasn't able to successfully implement that, but it is supposed to be for that. Send player type on connection. So when the devices are connected, now I want to send that, okay, I am player X and you're gonna be player O. So in this case, I'm just encoding a message. It's just normal JSON message. So I'm encoding the message. I'm sending it as the player type. And then there is this try session send. And you can choose to which peer you want to send the data. The nice thing about it here is that it has a catch block. So if it fails for whatever reason to send the data, you can know and do some error handling there. Then I do some updates on my end to say, okay, now this has been sent. So now the opponent is this peer, and the view state changes to play. So I'll take them to the play state. The message type is just very normal struct conforming to codable. So you can have this. This will be basically what you would use to transfer messages between devices. It could be any JSON model that you want. Now we get to the receiving part. So now I send the data. Now I want the other phone, or like basically the opponent receive the data. So on the receiver send, there is a delegate that says did receive data. And here you can use the same decoding for decodable to decode the message and do whatever logic you have in your app. And there are these two functions for these are the equivalent on the other type of receiving. So did it start receiving? So for a resource, you get a delegate for when the so when the resource started to send, and then you have one when it's ended. So you have the resource completely. And then you have one for the stream. We're gonna use only the first one, so just the data. Now here, so I want to send the player type. So as you can see, I decode my message, and then I have, I update everything on the other device about the player type. Now you're gonna be player O, and the opponent is player X. And then I'll change the view state here to be play. So now all of my devices are into the play state. There is another message that I have, which is move, and that is for transferring the game data. I'll get to that later. So here we have the game logic. I used this, I didn't implement the game logic. I used a tutorial from the Swift guy. I think he was one of the ones who implemented tic-tac-toe the easiest way, so I just used the code. But basically, most of the things happen in this function. So I have three properties. So I have a board, I have an active player, and I have a winner. And this function is called every time a button is tapped. So when a button is tapped, I check if it's the active player or not. Then I check if the board is empty on that point, or like on that button that is clicked, and if there is no winner. And if there is no winner, then I assign the board to be that player, and then I check for the winner. And now I have to transfer all of this data. I had some nice animations here that I kind of forgot to walk you through. So check the winner, and if there is a winner, then I say, okay, the winner is the active player. And if it's not a winner, then I toggle the player. And now I have to send all of this data to the other device. So that's how it's happening. So everything on top is just like a normal tic-tac-toe logic, but at the end, we have to send all the state now to the other device. Sending the game logic. So then again, it's just like another JSON message. So I encode the message, and then I use send to transfer data from this device to the other device. On the receiver end, I'll update the board, I update the active player, and I'll update the winner. So then the other device will have the updated state of the game. Okay, now I have a little demo for all of you to see, and I'm just gonna, yes. So you can see that it appears here. So this is the other device. I'll send the invite. Goes to the play. Then it transferred here. Who wins? Let's see. Can you see it? No? Okay. uh, yes. And there is also something that you can play again. So then it just clears the board. So that's the demo. I'll get back to the slide. So what are the challenges? I think one of the challenges is that when the devices go to the background, then it doesn't work anymore. So the Apple kills everything for you, even if you don't want it to. And then it has this line in the documentation that says, if the devices goes to background, everything is disconnected, but upon returning to the foreground, the framework automatically resume advertising and browsing. But the poor developer must reestablish any closed session. And that is not as easy as it sounds. It just becomes very complicated. Debugging. So it is a bit difficult to debug this because first of all, like it is multiple devices. If you have more devices, it even becomes more difficult. And then you have to go through all these delegates and figure out what is not working. Like, okay, what is going on here? I mean, there is a lot of catch and error handling already, but it doesn't become easier. Then unexpected behavior, or maybe expected behavior that you didn't expect. So it just sometimes you followed everything, but then devices don't disappear, or they appear but they are not working, so you cannot connect to them, or suddenly they disappear when they're not supposed to disappear. So there are all of those things that could happen. And the future of multi-peer connectivity, this is the thing that I personally wish for. I have no idea if anyone is working on that. But one of them is like cross-platform compatibility. So if we could use this to connect to other, for instance, Android devices or other OSs, enhance performance and reliability. I think it's been built, I don't know how many years ago exactly, but it hasn't been changed that much. So maybe it could be just improved or made easier in a sense. Yeah, and it would be awesome if we could use it to connect with IoT or smart devices. And better support for background mode, please. Like, why would it disconnect everything? Yes, thank you.